Hello, today we're going to talk about lesson 4.4 on variability. Our objectives are we can find measures of variability. Vocabulary alert. Our first vocabulary word of today is variability, which describes how spread out the data is. We also need to know about the range, which is the largest value minus the smallest value. We need to know what the quartiles are, which those divide the data into 4 parts. One of those includes the median, and we'll find out how to find the other 2 quartiles. And then we have the interquartile range, which is the 3rd quartile minus the 1st quartile. So let's look at our first example. We need to find the range and the 1st and 3rd quartiles for the data set. We have here a data set which starts at 85, and then we've got 92, 78, 88, 90, 88, and 89. We're going to start by ordering these in order from smallest to biggest. So our smallest number is 78. Then we've got 85. 88, another 88, a 89, a 90, and a 92. Now to find the range, we're going to take the biggest number, which is 92, and we're going to subtract the smallest number from it, 78. And 92 minus 78 is 14. So our range of this data set is just 14. Now to find the 1st and the 3rd quartile, we first need to identify what the median is. Now, I'm going to not actually physically cross out the smallest and biggest numbers. I'm going to just put a little mark underneath them until I find where the middle of my set of data is, and that is 88. So to find the 1st quartile, I need to look at everything that's smaller than my median. And I want to find the median of those numbers. So I want to find the middle number of 78, 85, and 88. So we can cross off the 78 and the 88, which means our 1st quartile is 85. Now to find our 3rd quartile, we're going to look at all the numbers that are bigger than our median, 89, 90, and 92. We're going to find the median of those 3 numbers. So we can cross off the 89 and the 92, and we get 90, which means our 3rd quartile is 90. Alright, let's try that again with another set of data. We're going to start by putting this set of data in order from smallest to biggest. So our smallest number is a 12, and we're going to work our way up to the biggest number, which is a 20. So we've got 12, 14, 15, 15, 15, 16, 17, 17, 17, 18, 19, and 20. Alright, so we're going to find the range, which means we're going to take the biggest number, 20, and subtract the smallest number, 12, from it. 20 minus 12, that's equal to 8. So our range is 8. Now, let's find those quartiles. So we need to find where the median is. We're going to get rid of, or not get rid of, put a little mark under the 12, under the 20, and we're going to make our way to the middle, which results in us being stuck between 16 and 17. So our median is going to be 16.5. So all the numbers that are smaller than that are 16 down to 12, and all the numbers bigger than that are 17 all the way up to our 20. So let's find the first quartile. We're going to find the median of the lower half of our data. So we can cross out the 12, 16, 14, 15, and we're stuck between two 15s, which means our first quartile, we need to add 15 plus 15, 15 plus 15, and divide it by 2. So that's going to give us 30 divided by 2, which is 15. So our first quartile is 15. Let's look for our third quartile. We can cross off the 17, the 20, a 17, a 19. So we're going to be between 17 and 18. We're going to have to add 17 plus 18 and divide that by 2. It's going to give me 35 divided by 2, which is 17.5. So our third quartile is 17.5. Alright, moving on. We've got another vocabulary alert, box and whisker plots. So all these are is they show the distribution of data. Now the middle half of that box and whisker plot, or of our data, is represented by a box with a vertical line at our median. The lower fourth and the upper fourth of our data are represented by our whiskers, which extend to the smallest and largest values. And I have an example of what a box and whisker plot looks like right here. Alright, our second example. We're going to use the given data to make a box and whisker plot. So, step 1 is we need to order the data and find the smallest value, the first quartile, the median, the third quartile, and the largest value. So if we put them in order, we're going to have 16, 17, 18, 21, 21, 22, 22, 33, 40, 42, 44, 45, 48, 49, 49, 55, and 62. So our smallest value is 16. Our largest value is 62. Our median, we eliminate numbers and we find that is 40. Then we find our first quartile, which is 21, and our third quartile, which is 48.5. We've done that already, or learned how to find those quartiles and medians before this example. So, now let's look at what step 2 tells us to do. Step 2 is to draw a number line and plot the points that we found from step 1. So we drew our number line, and you can draw it however you want, but my example starts at 10, goes up to 60, and each little mark goes by 5s. So we need to estimate where the 16 is, and that's about where our smallest dot is. That is our smallest number. Then we estimate where 62 is, which is where our largest number is. We put a dot at the 40 for our median. We have another dot for our first quartile, and then our last dot for our third quartile. Now you'll see I labeled the first and the third quartile as Q1 and Q3. That's just a shorthand way of writing first and third quartile. Now let's look at step 3. Step 3 is to just connect everything. So we draw a box around the first quartile, the median, and the third quartile, and we draw a line through where our median would be, And then from our smallest number, we draw a line over to our box, and we do the same thing from our biggest number. We draw a line over to our box. And that completes our box and whisker plot. Alright, let's look at our last example, comparing data sets using box and whisker plots. So these box and whisker plots compare the number of home runs Babe Ruth hit during his 15-year career from 1920 to 1934 with the number that Mark McGwire hit during his 15 years from 1986 to 2000. We need to first compare the medians and the ranges. So, if we're looking at this, it looks like Babe Ruth's median is larger than Mark McGwire's, and the range of Mark McGwire's is larger than Babe Ruth's. Okay, now we also need to compare the ranges of the middle half of the data for each of those. Now remember, the range of the middle half of the data, well, the middle half of the data is the boxes from our box and whisker plots. And it looks like that Mark McGwire has a larger box, so the range of the middle half of that is greater for Mark McGwire. Alright, that wraps up lesson 4.4. For the rest of your assignment, I would like you to complete the your turn problems on your notes for tomorrow. See you later.